Hello students, previously we have discussed the pure resistive circuit. Now we will also discuss the pure inductive circuit. What is the current, voltage and power waveforms during pure resistive circuit, pure inductive circuit. For example, this is the AC supply given across inductor. The current flowing through the inductor will be what? I of t. Then what is the current flowing through the inductor will be? First of all, let us name here V of t is equal to Vm sin omega t. Let us name here, it is equation number 1. What is the current flowing through the inductor then? Current flowing through the inductor is nothing but, yes, what is the current flowing through the inductor? Is nothing but 1 upon L integral V of t dt. V of t dt. That implies 1 by L integration. What is V of t? Vm into sin omega t dt. Okay. That implies 1 by L. Vm will be a constant. Integration of sin omega t will be minus cos omega t into 1 by omega. Because we are integrating with respect to dt. Omega will be a constant. A variable, no? Then Vm by omega into L into minus cos omega t, that is nothing but I of t. That is nothing but I of t yes. Therefore I of t is equal to what we have here? I of t is equal to Vm by omega into L is nothing but XL into this minus cos omega t can also be written as sin of omega t minus 90. Sin of omega t minus 90. Okay. Then what we get here? So this is the equation for Vm by XL. Vm by XL is nothing but Im into sin of omega t minus 90. So this will be current equation. Then can we find what is the value of power? Power is nothing but V of t into I of t. Yes. If we simplify that, then what is the power we get here? Just multiply both these values. P of t into I of t. And then what we get? Yes. Vm into Im into sin of omega t into sin of omega t minus 90. Yes. V of t is equal to Vm into Im into sin omega t into sin of omega t minus 90. Clear? Then after that, what we require to find here? Average power. What is average power? Average power is equal to 1 upon 2 pi integral 0 to 2 pi P of t dt. You again substitute the same formula, but this time what is the average power for pure inductive load will be 0. If you solve this, you get the answer. We also draw the waveform here. If you try to observe the waveform, here, okay. For example, this is the voltage waveform. If this is the voltage waveform, then similarly, what is the current waveform we will be solving? If you observe the equation, this equation, current is shifted by 90 degree. For example, this is what? 0. This will be exactly 90. Yes or no? Am I correct? 90. This will be what? 180 degree. exactly this will be what? Pi by 2. This is pi, this is 2 pi. Now our current waveform is starting from 90 degree. It is starting from 90 degree. It is displaced from 90 degree. Okay. Now before that we have now if you observe this, voltage is positive during 0 to pi. Means if you observe this, voltage is positive. Let me change the ink first. Voltage is positive, current is negative. Voltage is positive, current is negative. Voltage is positive, current is negative. Then what is the power? Power will be negative during 0 to 90 degree. Okay, power will be negative. In the same way, from 90 to 180 degree, power voltage is positive, current is also positive. Then power will be positive. Okay. In the same way, from 180 to 270 degree, from 180 to 270, what is the current we have? Current is positive, but voltage is negative. Voltage is negative means then we get power will be negative during this peak. Next, what about this one? From 272, from this 270 to 360 degree, current is negative, voltage is also negative. If current and voltage both are negative means we get power will be positive. Okay. So this is what the power waveform here. This will be power, this will be V of t, and this will be I of t. Hope you understand this point. Okay. Next, average power will be here. If you simplify this, what we get here? Average power will be 0. Okay. Thank you.